Okay, we're going to talk about complex numbers. Usually we skip this section, but there are a few things that you need to know about complex numbers in future sections. So the first thing we want to do is talk about the form a plus bi. Gauss is who discovered complex numbers, how to write it this way. This is the real part. That's a real number. And this is the imaginary part. And you know that because of the I for imaginary. So, in other words, the number 1 plus 3i has the real number 1 and the imaginary number 3i together. Okay, and actually there is an imaginary plane. You don't have to really know this, but I'm just letting you know where that real part, 1, that represents 1 plus 3i on that imaginary plane. But like I said, we don't really need to know that. And then say the number 8, you can write that as 8 plus 0i. So it just equals 8. And then if you have the number 2i, you can write that as 0 plus 2i, which is just 2i. Okay, so every kind of number can be written in terms of this complex. This is called a real number, this is an imaginary number, and this is considered a complex number that has both. Okay? Usually if a number's like this, we just use imaginary, the term imaginary. We don't use complex. And usually if a number's just like this, we use real or integer, whatever kind of number it is. Okay? So that's the a plus bi part I wanted to show you. And then we need to talk about I. So if you have the square root of 9, that can either equal a positive 3 or negative 3. If you have the square root of a negative 9, remember a negative number is just the positive number multiplied by a negative 1. So we can write that as based on remember when you have a product under the square root, you can separate those products like that. So this is like a 9 times negative 1. Square root of 9 times square root of negative 1, I should say. Okay? So this is the square root of 9. That's where you get your 3. And the square root of a negative 1, that's actually I. So the people who made up imaginary numbers just designated, we'll call the square root of negative 1 I. So therefore, I squared is negative 1. So this is I, and this is 3 plus minus 3. Usually we write the I after the number unless it's not a perfect square. For example, if you had the square root of a negative 11, you would actually write that as plus minus I square root of 11. You would put the I in front so as not to confuse it with this. Okay? And the last thing are conjugates. We need to talk about those. So a conjugate, there's a formula. Well, let me just say that if you have given a plus bi, a minus bi is its conjugates. Okay, so only the middle sign changes. When you multiply conjugates, you get a number. You get a real number. Okay, so let's just FOIL this real quick. A plus BI times A minus BI. And if you notice, it's kind of like the difference of two squares thing, so our middle terms are going to cancel. So we get A squared. We're going to FOIL this. First, outer, inner, last. A squared minus ABI minus, plus ABI. Okay? And then this is going to be a minus B squared I squared. Okay? So these cancel out because one's plus, one's minus. The A squared comes down. And if you notice this, we said up here that I squared is equal to -1. So you have a -1 times a -1. So that becomes a positive. So you get A squared plus B squared, which is going to be a number. So let's do an example. Let's try 1 plus 3i times 1 minus 3i. So since we know the two middle terms cancel, and since we know this becomes positive, we really only need to look at the numbers. And so our A is 1, so A squared is 1 squared. Plus 9, or I should say 3 squared. And then plus 3 squared, so that's going to give you 1 plus 9, which is 10. So this times this gives you a real number, like I stated up here. When you multiply conjugates, you get a real number. Why is that? Because you're always going to get an I squared term when you multiply the conjugates. And it's always going to have that negative because one's positive, one's negative. And then you're always going to have that negative times a negative to give you that, to get rid of that I. Okay? That's pretty much all I want you to know about imaginary numbers to help you move forward. Okay?